Hello students, this is Math 150 3.7 Elasticity of Demand, and I'm trying to videotape my lessons for you all during this time of the coronavirus. Make sure you get the handout, which I have online. It's Math 150 Elasticity of Demand. And we're going to do example 1. A man owns an Oriental market, wants to increase the sales of a particular soda. When he makes the price of the soda $3.25, he sells 100 bottles of the soda. In order to make more money from the soda, he decides to raise the price to $4. However, at this price, sales drop significantly, and he only sold 80 bottles of the soda. He wants to know if he can predict how changing the price will impact the change in demand. And it turns out that can be measured. We're going to be looking at elasticity of demand, which means how price affects demand. So the first thing we're going to need to do is look at a demand equation. Right now we don't have one. We're going to assume it's linear. We've done this before. Look at part A. It says create the demand equation for this product, x as a function of p. So when x is a function of p, we're looking at the ordered pair px. Okay, this is backwards. And sometimes I just really have to go to the graph and note that the price is on the horizontal axis and demand is on the vertical axis. So when this is happening, price is the independent variable and demand is the dependent variable. So the demand depends on what price you set it at. So when we have it in this order, x comma p, now we've had it where it's p comma x, or I'm sorry, I even said it wrong, p comma x, we've had it backwards. Or which way is backwards? I don't know. It just depends on how you're analyzing. We're doing x as a function of p, so that's x is equal to f of p, where demand is a function of price. So what we want to do is make sure we put our price first and our demand second in the ordered pair. And we have two ordered pairs, and you can stop this at any time and make sure you're seeing where these ordered pairs come from. I got it from the words of the example. Now we're going to put these values into our calculator. You know how to do that. So you go stat, edit, and you put your price in first and your demand into L2, and we've got those two ordered pairs in. Then you do your stat, calculate your linear regression, and it will give you y equal ax plus b, and you should get negative 26.7 for a, and b is 186.7. Why don't you stop your video, the video, not the calculator, stop the video and see if you do come up with those values. So hopefully you did that, and come back and notice that I'm going to write this as y equals negative 26.7x plus 186.7 according to the calculator. And now I am going to put in the correct x and p in their right places. So what I do, and it helps me, I don't know, however it helps you, is to look at the prices where the x usually is. So the price is going to go where the x is, and then x will equal that equation because x is on this axis, which is normally y. All right, here is your demand equation where x is solved for. Now if we wanted to, we could solve for p in this equation, but we don't need to because we're going to look at elasticity of demand. I've got stuff on my paper. X is a function of price. Now let's take a look at Part B. Part B in this problem says graph the demand curve. Well, it's actually a straight line on this in this window. So I have already set up the window, so you can stop the equation. Sorry, I am not a very good videotaper, so I'm learning. So you can stop the video and see if you can plot this. I recommend plotting the two ordered pairs. 3.25, so 3.25, comma 100, about right there, and 480 for up here at 80s, I don't know, right there. So this is 3.25 comma 100, and this is $4. So I'm just takes 2 points to graph a line, and I'm going to try to connect these. There we go. And there is our equation. That is our demand equation. You can do this in your calculator as well. I've given you the window. So you're going to go to y equals, now this whole x and p reversal is going to get a little tricky. So if you wanted to put it in here, you put in negative 26.7x plus 186.7, your window. I already gave it to you as 0 to 7 by 1s and 0 to 200 by 50s. And then if I hit graph, there is the equation using your calculator. All right, so that is part A of elasticity of demand. And I'm going to keep this short because it's easier to upload shorter videos than it is longer videos. So I'll be back to finish this worksheet.